Alright, so what we're going to do today is easy. It's a little bit long, but if we don't do this today, then what we do tomorrow is much harder. So make sure you do it, even if it's long and boring, because it'll make tomorrow's lesson much, much easier. We're doing what tomorrow? So tomorrow I'm going to give you chemical reactions, and I'm going to say we want to produce a certain amount of stuff. How much of the reactants do we need?
So,
to do that,
okay, you're going to give us that.
all right, whatever, Monday, you know what I mean.
You got an eye, you know.
This is an I, this is an I. Okay, so this all falls under the category of what's called stoichiometry. That'll be like what we're doing for the next 2 weeks. Today we're just going to write these mole ratios. So, let me write a few things here. When you balance an equation, you are finding the ratio so it's the ratio of the number of moles of stuff that you use. Number of moles used so the stuff that we use, what's that called? Those are the reactants, right? Whatever we're using up, those are reactants. It's like the ingredients when we start out, right? To the ratio of number of moles produced. And the stuff that's produced, those are the products, right? That's the stuff the arrow points to in the chemical equation. Use mole ratios. It's just the ratios of the numbers in the balanced equation.
Please excuse the interruption. Mr. Blackwell, report to D121, please. D121.
So let me use a couple examples here. Let's do one that was on the quiz. This will be sodium plus oxygen produces sodium oxide. This reaction would happen if you just took a piece of sodium metal and left it running out. We just reacted the air over time. And this is going to be a 4, this is going to be a 2. I'm going to assume at this point you know how to balance, and I'm not going to go through the good steps. Oh wait, so what am I doing? I'm not balancing. Okay, so there's our reaction, right? This is the one we're looking at. And so we want to use the ratio, but write down the ratios of these things. So basically the ratio of sodium to oxygen, the ratio of sodium to sodium oxide, and so on. So all we're going to do is just list ratios today. I'm running out of space. I'm going to have to write here, I guess. All right. So we're going to start with sodium. So sodium, there's a 4 in front of it. So we're going to write the ratio of sodium to oxygen. So it'd be 4 moles of sodium to 1 mole of O2. So whenever there's nothing in front, you know that means a 1, right? And then we're going to also list the ratio of sodium to sodium oxide. So that would be 4 moles of sodium to, moles of sodium to 2 moles of sodium oxide. And I know you guys know that 4 to 2 ratios is 2 over 1, but I just want to write it this way for now. All right, so those are the two ratios that involve sodium on top. So if we were going from one other thing to sodium to figure out how much sodium there was, these are what we would use. Now we're going to do two with oxygen. So we're going to do 1 mole of O2 to sodium, 4 moles of sodium. And basically we're going to do 6 of these. So there's going to be the reciprocal of each one is going to be somewhere, right? So this one and this one are reciprocal. We're going to do oxygen now to sodium oxide, so 1 mole of O2 to 2 moles of NaCO. And the reason we're doing this is that we're going to use these like conversion factors tomorrow, right? Like you remember when we did conversions in the metric system, we did 1 meter over 1,000 millimeters, right? And then we use that to convert. That's what we're going to use this for. Like if I look at this thing here, it's set up to tell me how much of this stuff I need if I want to make 2 moles of sodium oxide. What if I don't want to make 2 moles of sodium oxide? What if I want to make 6 moles of sodium oxide? I'm going to use these mole ratios to figure out how much of each of these things I need. So that's what this is going to be for. With that, we're going to dig into tomorrow and get this stuff out of the way. I'll do the last one. So last, we're going to do sodium to each of these. So we'll do 2 moles of NaCO over sodium, which is 4 moles of sodium. And then finally, sodium oxide to oxygen. 2 moles of NaCO over 1 mole of oxygen. So there's 6 total for a reaction that has 3 things in it, right? This has 2 elements in 1 compound, 3 different things in it, so we end up with 6 ratios. Now, if you understand how math works, if I have 4 things in it, that number is going to double. It's going to be 12. So let me erase up top now, and let's do one more. And let's just see how it changes. And again, I know this is tedious, but if I just skip straight to tomorrow's lesson, I feel like a lot of people will get lost in the shuffle. All right, let's do another one from the quiz. It's potassium plus this stuff, B2O3, produces potassium oxide and boron. And I'll just give you the answers to balancing. So remember, when I give you a worksheet today, you're going to have to balance these things before you can write the mole ratio. That's where the ratio comes from. If you don't balance it, then everything's going to be 1 over 1, which will be senseless. Okay. Everybody caught up here? Yeah, I gave you I balanced it already. They're right there. All right, so let's do this one now. So we're going to need 4 columns. So we're going to do potassium first. So it's going to be, let me get rid of this. So it's going to be 6 moles of potassium over 1 mole of this stuff. Okay. And then we're going to do the ratio of potassium to potassium oxide. 6 moles of potassium over 3 moles of potassium oxide. And then we still got 1 more for potassium. We've got to do the ratio of this to boron. So we'll do 6 moles of potassium over 2 moles of boron. Obviously that simplifies to 3 over 1. All right, so that's the first 3. That's for potassium. Now we got to do all the ones that involve B2O3. So it's going to be 1 mole of this over 6 moles. Okay. And we're going to do this one to this one. 1 mole. And remember, tomorrow when we use these, whichever one you're trying to figure out is the one that you're going to put on top. This one to this one. So 1 mole of 203 over 2 moles of boron. All right, almost there. We'll do this one next. 3 moles of K2O over first one, 6 moles of K. And we'll do this over this. And finally, potassium oxide to boron ratio. 3 moles of K2O over 2 moles of boron. And so we do the ratios for all 4 of these. So now the last one is boron. So 2 moles of boron over 6 moles of potassium. 2 moles of boron over 1 mole of P2O3. And finally, 2 moles of boron over 3 moles of H2O. Well, like I said, this is a bit of overkill, but it's important because tomorrow you're going to need to know these ratios. And I'm going to say, give me the ratio of these things, and there's going to be a lot more steps involved. So knowing this allows us to go to that step. Questions on this?
Shorter way to do it? No,
Each one's different, although there are the reciprocals of each one. So it's like we wrote it twice, sort of. What do we get out of this? This tells us if we need to make a certain number of moles of boron, looking at this one here, this tells us we're going to need 3 times as many moles of potassium. Right? No, you don't have to simplify it. But we're going to use these to convert just to figure out. So tomorrow what I'm going to do is I'm going to say I want to make 27 moles of boron. How many moles of potassium and how many moles of this stuff do I need? And you're going to figure those out using these things. So you won't have to write all of them tomorrow. You'll just have to know, okay, I need to use this one and this one. Or actually, no, it'll be the other 2. It'll be this one and this one to figure out how many moles of those 2 things I need. So whatever you're trying to figure out is what will go on top. But we'll do that tomorrow. Today I just wanted you to get the idea of what the ratios are and what these numbers really represent when we balance the equations. All right, this is a long worksheet. Just do 2, 3, 4, and 6.